Ready to go. Not sure about anything today. All right. So I think I have a warm up for us, maybe somewhere. Here's a question that might be on Friday's quiz. Says, Sari realizes that when she makes calls, you don't have this, so it's just a warm up. When she makes sales calls to 12 stores, she sells 60 boxes per store. Every time she makes an additional sales call, the number of boxes she sells decreases by 3 per store. Find the number of stores she should visit to maximize the number of boxes she sells. Okay, so what's going on right now? And it will be set up. There will be a little chart for you on the quiz, okay? So what do we know right now? 12 stores and 60 boxes, which I think is 720. All right. Then what? Okay. So if she went to 13 stores, this would decrease by 3. And I don't know what that is. Can someone help me out? Okay. Now, what's happening here? How do we write an expression? You could do a couple more by hand if you needed to, but how do we write the expression for this column? It started at 12 and it's going up by 1. So X is the number of additional stores that she's going to go to. Okay? What's going to happen to the number of boxes she sells every time she adds one to that other number? So we do, yes, be -3 per, starting at 60 stores, right? Then we need to graph it and find a maximum. Anybody figure out, looking at this, what our window should be? How many times could she possibly take 3 away before she ran out? 20 times? So I think 0 to 20 would be a good window. If you didn't have that, it's okay. I'm not checking your window. Okay. And we already know it's around 700 something. So I don't know. I would probably just go like 850 or 900 just to make sure it was working. All right. Someone might have to tell me what this was. 60 minus 3x. I remember that part. Was it 12? Oops, I forgot the x. 12 plus x. And for a window, we decided like 0 to 20 and then up to like, I don't know, 800 maybe. Okay. And then I need to find the maximum. And it's somewhere between 0 and 20. I want to just be lazy and type it in. I got 4 and 768. Did anybody get that? Did anybody find the maximum at 4? Anybody need help? Their calculator's not working how they want it to. Tristan, what's that quizzical look? You need a window check again, or? Everybody okay? So the max was at 4,768. Is that what it was? I don't remember. Yeah. But the question will have a blank that says find the number of stores, number of total stores, and then it will say blank, okay? Because I'm trying to give you a hint that what do you have to do with this 4 number? Yeah, you have to plug it back in here because the number of stores she should visit to maximize the number of boxes should be 12 plus 4 or 16 stores. Okay? We're going to do okay on this? We'll try to practice a little more, but that's the kind that's on the quiz. That and a throw-up question. Do you know what I'm talking about? Like, here's the equation. I give you the equation. Say we threw the ball up in the air or dropped it off this building or whatever. How long till it hits the ground? So then you just want to find the 0 on the graph. All right, more today. We're going to talk about domain and range some more. This is 1B towards the bottom. I hope you remember this. Yes. 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 It's not going to have any old stuff. It only has 4 sections on this Friday's quiz, and it's all new stuff. And I have a review for you. I have it run off so I can give it to you anytime, just if you want to know what the quiz is going to look like, okay? Talking about domain. Can everybody repeat after me? Domain is all real numbers unless there's a square root or an x in the denominator. Okay. Students get so freaked out by finding domain when they don't have a picture, okay? But it's always all real numbers unless there's a radical, and then whatever underneath the radical has to be greater than or equal to 0, because we can't take a square root of a negative number. If it was a cubed root, then we could take a cubed root of a negative number. Does everybody understand that? The cubed root of -8 is -2, because negative times negative times a negative, okay? But as long as you had a square root or a 4th root or something, you'd have to say what's under there has to be greater than or equal to 0. And if there's an x in the denominator, all you have to worry about is that denominator can never equal 0. Can't divide by 0. All right, so we started, I think we left off on 12 and 13. Does that seem right? Okay, so I want to do one more quick review about graphing, because this ties into the rest of the lesson today as well. Is this a function? You don't have this. Okay, why? Very good. The domain, remember you go left to right. Go kind of bracket. Okay, range. Bottom to top. And why is it infinity? Because, well, and because the arrow is climbing, right? It's going up. Okay. Is this a function? Are you sure? Okay. Passes the vertical line test. It wouldn't pass a horizontal line test, so it's not 1-to-1, but it is a function. Okay, domain, parenthesis, -4. We're going left to right, so it should be -4. You're right. I wrote that down wrong. But it doesn't include -2, right? -2, and then does everyone understand when I do this? It means up to -2, but not including -2. And then starting on the other side of -2, but not including -2, it goes to where? To 2, same thing, and then 2 to infinity. Ugh. Okay? Icky. Range, bottom to top. Oh. I would have said -4, but this is going down, right? So it is negative infinity. Eventually there will be values below -4. Up to 1, what kind of bracket? The square hard bracket, because does it have some values at 1? Yeah. If it has even one value where it actually has a y value of 1, you have to include it. All right. So we're good with graphing, I think. The question is, when there is no graph, how can we determine if it's a function? We could try to graph this, but what would we have to do first? Yeah, we'd have to get the y by itself. And most of us would probably forget what? Plus or minus the square root of x over 5 equals y minus 1. So then we'd have to add over here. Okay, if you wanted to type that in your calculator, you'd actually have to type that in y1, and in y2 you'd have to type this. to get both the plus and the minus branch. The plus or minus out in front would be, so what you're going to get is a sideways, two branches of a sideways parabola. Now, anytime there's a y squared, it means you're going to get two different answers for out for x. Okay, so this is not going to be a function. We still could talk about domain and range because the sideways parabola, but I vote we just don't. Are we good? All right, what about 13? Here's the graph. How would you type that in though? Maybe I should ask that before I... Yes, you got to have parentheses around the whole top and the whole bottom, right guys? Okay, so the graph looks like this. Can you see it? We should probably have the light off, but let me try and make it a little bigger. Yeah, if you want to hit the lights, that'd be great, but... Okay, what do you think? It does kind of look like it's flattening out, but does that matter? It still passes vertical line test? Everybody okay with that? Yes, it's a function. Domain and range is much more miserable, right? Okay. Domain is left to right. There are some places where it's undefined. Could anybody predict where those would be? Do you remember what we just said out loud a minute ago? It's all real numbers unless there's what? X in the denominator. So we need to say what is making this denominator undefined. X squared minus 8x plus 15 can't do what? Yes. So if I factor, does that work? X minus 5 and x minus 3, guys? So where are the undefined places? X cannot be or positive 3. Does that look like it might be true that there's undefined place at 3 right there and over here at 5? So how would we list the domain for that question? You know what? I'm going to get this off the screen so we can use this extra space over here. Okay, maybe I'm not very good at that. So for this question, the domain would be, we could write all real numbers but 3 or 5. Or we could do the real funky up to 3, everything between 3 and 5, and everything from 5 to infinity. Is everybody okay that that means not equal to 3 or 5? What we're going to learn today is that that is called continuity, that this graph is not continuous, that there are places where it's discontinuous. The two values that it is discontinuous at is when x equals 5 or x equals 3. Every other value works, but I can't put in a 5 or a 3. And that's going to be on the quiz as a question that says, is this graph continuous at? And if you put the number in and you either get an imaginary answer or you get dividing by 0, then you're going to say, no, it's not continuous. All right, range. Does anybody have this graphed on their calculator? Can you find this maximum point for me? Because this is actually on the quiz as well, where there's a crazy graph and you have to graph it. I just need to find that value right there. Might need a window like, I don't know, negative 100 to 50 or something. 4 point something is the x. And the y value? Okay. So my question is, from bottom to top, what is the range for this graph? Okay, it has arrows here, right? So it goes down. Does everybody see what I'm talking about? Here, let's talk about it again. It has this, this, this. These would have arrows. So it goes down forever. So from the bottom, we have a negative infinity. But at some point here, there's a gap in our graph. What was the number that we need from that ordered pair over here? No, if we're doing range, y values, right? Okay. And it hit that value. We rounded probably, but it hit that. It doesn't have an open circle on the graph. And can you tell what's happening then? Where did it start up again? Can you tell where there was values again? Above the x-axis, right? How do we say that? Yeah, 0 to infinity, because it's got arrows here going up. Actually, I think that's not right. Because can it be 0, guys? If we put a -3/2 in there, someone trace, who has the graph, trace this piece out here. I think it actually goes a little bit negative. Yeah, I won't ask you to find range on this kind of question. I promise. Did anybody trace out here to the left? Can you just type, Tristan, do you have it graphed? Can you just type trace -8 or something, -5? What do you get for the y value? Okay, so it does go a little bit negative. So this should be something else. Okay, we're moving on. I won't ask you the range on one like that, I promise. I will ask you a goofy range, but it's a graph that you're going to have to estimate from. In other words, if I gave you this graph, I would have to take a lot of different, slightly different answers, right? I could give you this point, but I'm going to ask you domain and range estimated from a graph. All right, we're going to talk about domain just another second. It doesn't ask for range, and you don't have these. This is just extra practice. But students really struggle with this idea of what are the restrictions on the domain. What can x not equal here? That's wrong. X can be 0. If I put a 0 in, I will get -2/12, which is okay. What can't equal 0? The denominator. So I have to set the denominator equal to 0 and figure out what values of x that would mean are a problem. That factors x plus 3, x plus 4. So what are the two values I can't have? Okay, can't equal -3 or -4 because it would make the denominator 0. Otherwise, it's all real numbers. Okay, what about this disaster? This would be a good one to graph, but what did I say about underneath a radical? Do you remember? It has to be positive. So a squared minus 4 has to be greater than or equal to 0. If we factor that, we get a minus 2, a plus 2 is greater than or equal to 0. So we have 2 and -2 to worry about. If you actually graph this, it looks like this. Okay, so what are the restrictions on x? It can't equal anywhere in between there, right? So can you, if this is -2 and this is +2, can you describe the graph in interval notation, the domain in interval notation? Sorry. Anybody think they got it? Left to right. Yeah, but I want an interval notation. So what can it equal? -2. Actually, it could equal, because you could take the square root of 0, right? If I put a 2 or a -2 in here, I get square root of 0, which is 0. So it's actually a bracket. And then what? Okay. One more. What happens here? Well, I just want the domain. So because there's a radical, whatever's underneath it has to be greater than or equal to 0. But because it's in the denominator, can it equal 0? No. Whatever's underneath it has to be greater than only, can't equal 0. So solve that, and what are you going to tell me? X has to be greater than -3. So that, as an interval notation, would be -3 to infinity. Okay? So a little practice on that. Now, the second part of the lesson today is from, I thought I had a, guess not. This is from 1B, okay? 2B, I'm just kidding. 2B. We're going to talk real quick about average rate of change. Average rate of change is just slope, okay? You're going to see it on a quiz and you're going to get all confused and you're going to think it's really hard, but it's not. Can we just review real quick? How do you find slope between two numbers? Yes. So you don't have this question, but it would be 395 minus 380 over 15 minus 12, which would be 15 over 3 or 5, would be the slope of the line between those 2 points. Everybody remember how to do slope? Okay, so average rate of change, which is a part of the 1.1 section that's going to be on the quiz Friday, says between x equals a and x equals b, the function changes from f of b to f of a. The average rate of change is defined by the expression f of b minus f of a over b minus a. It just means put the numbers in the function and find the slope. Don't be all confused by that notation. So this is what the question will look like on the quiz. Find the average rate of change between, and it'll look like this. Okay, any ideas how we start? X equals 3, what are we going to do with that? Plug it in. So I'm looking for an ordered pair starting with 3. So I plug it in here and I get 3 times 3 minus 4, which is 5. Okay, then I'm going to go back and do 8. So it's going to start with x equals 8, and how am I going to find the y value? 3 times 8 minus 4, 32 minus 4, 28. Did I get that right? Okay. Did I lose anybody yet? How we got those ordered pairs? Okay. All we have to do is what? Did I do something wrong? Yeah, 24 minus, okay, yeah. Sometimes, thanks. Fix me, I'm broken. Okay, 24 minus 4 is 20. There we go. Okay, now we have to find the slope. So the average rate of change is the slope. So we just do 20 minus 5 for the y's and 8 minus 3 for the x's. And we get 50. What? That's okay. Remember, it was 3 times 8 minus 4, so it was 24 minus 4 is 20. We okay? Yep, I know I'm just confusing you. Okay, the y's change 15, the x's change 5, so the total average rate of change is 3. Now, we're going to talk in a second. Average rate of change, did I do something else wrong? Okay. Average rate of change depends on what points you put in. It's not the same all the way along. Normally. What would this graph as though? This is a line, right? So anywhere along that line, the rate of change is just the slope, which is 3. Yeah, which is what we got. Okay. A parabola doesn't have a slope, right? And if you think about a parabola for a second, is it changing as fast from here to here as it is from here to here? No. Okay. It's slower here and faster here. The slope is different. So it's going to depend what we're given for x values. All right. So can you try this one on your own? Put a 2 in, see what you get out. Then put a 4 in and see what you get out. And then do what? Yes. Good job. Did anybody, are those right? 2, 6, and 430? Okay. Anybody get 12? Everybody get 12. Anybody got a question? So the hardest part about this is remembering what it means when you see find the average rate of change. If you remember what it means, you'll be fine. Yes. Yes. The average rate of change is 12. On the quiz, make sure you show some work. So if you made a silly mistake. No, it's fine. No. It would be the rate of change. All right. This is talking, when you get to calculus, you do this all the time because it has to do with limits and lines of tangency and all kinds of weird things. But my question here says, which is greater, the average rate of change for x squared between 0 and 1 or between 4 and 5? Kind of already talked about this. If I had f of 0, I'd get out what? For x squared, guys? 0. If I put in a 1, I'd get out 1. Okay? If I found the ordered, or the slope, I'm sorry, between 0, 0 and 1, 1, I'd get 1 minus 0 over 1 minus 0, which is 1. If I used f of 4 and f of 5, I'm squaring them, so I get 16 and 25. So my ordered pairs are 416 and 525. 25 minus 16, 5 minus 4 is what? Is that 9, guys? So it's much steeper, yes? Does it make sense? This parabola looks like this, right? Is it going up faster? It's almost flat down here, right? Compared to how fast it's going up here. Any questions? All right. This says what's the greatest rate of change between 0 and 2, and it wants you to do all 3 different functions. So for f, if I put in a 2, I get out a 2 because it's just linear. It says f of x equals x. If I put in a 3, I get out a 3. What would the slope be then? Yeah. All right, for g, if I put in a 2, I square it and I get out a what? And for g, if I put in a 3 and square it, I get out, okay? 9 minus 4 over 3 minus 2 would be 5. For h, I should be not writing these like their function notation. If I put in a 2, I get out 2 cubed would be 8. If I put in a 3 and cube it, I get out, so 27 minus 8 over 3 minus 2 would be 19 over 1. So which of these has the average greatest rate of change? H of x, right? The cubic is going up faster. All right, this question is leading into what happens in calculus. So I kind of just want to show you this. So grab a calculator real fast and help me type these things in. It says x squared, okay? If I put in a 1, I get out a 1, right, guys? What happens if I put in a 1.1 and I square it? 1.1 squared, 1.21. All right. If I do the slope, 1.21 minus 1 would be 0.21. On the denominator, 1.1 minus 1 would be 0.1. And what is 0.21 divided by 0.1? Okay. Now it says, what if you made that interval smaller and you were only looking from 1 to 1.01? Well, 1 would stay 1, 1. But what happens if I put 1.01 and I square it? Now I need somebody to help me nice and loud. Like that, 1.01 squared. Okay. So now when I go to do the slope, this minus this would just be 0.0201. In the denominator, 1.01 minus 1 would be, so now help me out. Okay, one more time. 1 stays 1. What is 1.001 squared? Okay, so now if I did the slope, what would I get on the top? Over, which is, as we cut that interval, okay, first we were looking at a width of 1/10, right? From 1 to 1.1. We cut it down to 1/100th. We cut it down to 1/1000th. What happens to the rate of change? It's getting closer and closer to what number? 2. Okay, so what does the average rate of change appear to be approaching as we cut it closer and closer to 1? It's approaching 2. This is called the instantaneous rate of change, and it has enormous importance in calculus. Okay, I'm not going to ask you that. I'm just showing you where this is really used later, this rate of change business. All right, so on either the blue sheet or the homework checklist you picked up on Friday, this is the part 2 assignment for 1.1. And it's very clear down here that the directions need to be changed when you get to 66 through 72. Don't do what it says, because what it says is a very complicated thing you'll do in calculus, but instead I want you to just find the average rate of change between x equals 1 and x equals 3. So you're going to put in a 1, get out a number. You're going to put in a 3, get out a number, and then you're going to find the slope. That makes sense for those questions? 66, 68, 70, and 72. Okay? It says down here you can do more practice, but if you think you got it, I'm good. Any questions about rate of change? All right. Now, we're supposed to start the next worksheet 3, side A today. No, we're good. We already did all this, okay? So I'm not going to freak you out. Just take it out. All that's on side A is domain and range. And we knocked this out of the park already. I'm going to not do this warm up. We can come back to it maybe. All I want to do is talk about domain and range and continuous. Okay, by looking at the graph of a function, you can determine the function's domain, range, and estimate the x and y intercepts. The x-intercepts are also called the zeros. That's what it's called on our calculator, right? And remember, to get the y-intercepts, we put in x equals 0. So it says, eventually in this section, we're going to do some graph analysis. If I just took that little, let me see if I can do this. If I took this little bitty graph and made it bigger, can anybody tell me the domain and range from that graph? You would have to type the equation in and find this maximum point, but what's the domain and range? First of all, is it a function? Yes. The domain, left to right. Okay. Did I know that from this? The domain is always all real numbers unless there is a radical or an x in the denominator. Was there either one of those here? So I knew it was going to be all real numbers. Okay, what about the range, bottom to top? It's the y value. A whole bunch of you said that. And it would have a square bracket because it does actually hit that value. There's not like an open circle, okay? All right, let's talk about... all right, this is a cubic. It's a little bit hard to read. 4 cubed roots of x minus 1 minus 4. It wants the x-intercept, y-intercept, zeros, all kinds of good stuff. Can you just tell me domain and range? Can you tell? Now, because this is a cube root, remember I said this earlier, you can take a cube root of a negative number. That's why it's going left and right forever. So even though it has a radical in it, it's a cube, not a square root, so it can be all real numbers. So the domain is all real numbers. And what do you think about the range? All right, the y-intercept is what we get when we do what? Yes. So the y-intercept would be when x equals 0. So if I put a 0 and 0 minus 1 is what? Negative 1. Cube root of negative 1. You can cube root negative 1. Be negative 1, right? Because negative 1 times negative 1 times negative 1 would be negative 1. Yeah. So times 4. No, it's a cube root. So you don't get an I. It's just negative 1, okay? So negative 4, and then it says minus 4, which would be negative 8, which does not look right for their, oh, maybe it is. They're counting by negative 2 or by 2s on their graph paper. All right, can anybody tell what they think the x-intercept is from the graph? Which are also called the zeros. We could put a 0 in. 4 cubed roots of x minus 1 minus 4. How do we solve that? Isolate the radical. Add 4 to both sides. Divide by 4, which would give us what? 1 equals the cubed root of x minus 1. If I cube both sides, what will I get? 1 times 1 times 1 is? Add 1 and I get 2. So putting in a 2 would give us out a 0. Does that look right on this graph? Yeah. And we could have typed it in the calculator. All right. Last thing I'm going to do today. We'll start with the domain and range again tomorrow. You can interpret from a graph, and this is on the quiz. What is this saying? Is that an X or a Y value? F of negative 2.5. Negative 2.5 is an X value. So I go to X equals negative 2.5, and I figure out the Y value, which looks like it's 12. I could also get it by plugging it in here. Negative 2.5 minus 3 by negative 5.5 would make it positive, times 2 be 11, plus 1 is 12. Whew, it worked. Okay. Put in a 1, means when X is 1, Y appears to be about what? About 5. If I put it in, 1 minus 3 is negative 2. Absolute value would make it positive 2. Times 2 is 4, plus 1 is 5. Okay, what if I put a 7 in? Looks like it comes out 8. Okay, 7 minus 3 is 4, times 2 is 8, plus 1 is 9. 7 minus 3 is 4, times 2 is 8, plus, yeah, this is supposed to be 9. I don't think our graph is very accurate. Anyway, I think on the quiz, you just literally have to estimate from the graph on one of those, because there's no equation given. All right, so we'll start with some more domain and range tomorrow, and then the new concept we're going to do tomorrow is symmetry. So the only thing you need to work on are the first 2 book assignments on the blue sheet. They are both from section 1.1, pages 9 through 11. Does everybody know what I'm talking about? If you don't, look on the homework check sheet. It's the second and third one from the bottom. Any questions?